Hello, welcome to the course of UAV. So here the UAV stands for Unmanned Aerial Vehicle, or we can also say it as Unmanned Aircraft System. So this sector is facing a massive expansion from all point of view, and here the range of devices expanding from micro drone weighing a dozen of gram to large machine of size of a passenger aircraft. So once it was reserved for specific military operation, but now the drones are used for an increasingly wide number of civil applications. And coming on, there is a no doubt unmanned aerial devices will fundamentally change the face of the air transportation industry. So let's learn about this UAV. So our first chapter is UAS. So coming to the first chapter, UAS. In this chapter, we will discuss about what is UAS, history of UAS, and the classification of UAS. Then we will discuss about the two technologies, Wave and LTE device to device, and then we will discuss about the UAV application. So starting with the very first, let's discuss about what is UAS. So here UAS stand for Unmanned Aerial System. So here it is an entire package used to operate the system. So it include UAV, the ground control system, camera, GPS, and all the software. And here you require a high skill. So high skills are needed to operate the system, and many expensive tools are required for its maintenance. So this is a UAS, that is the complete package that is used to operate this system, that is UAV system. Next, what is UAV? So UAV stands for Unmanned Aerial Vehicle, and it is the actual aircraft that flies around to collect the required data and imagery or the information. So the UAV operates with various degree of autonomy, like it is operated by a human operator through remote control, and it is also operated by an onboard computer. So UAV were specially designed for the mission that are too dangerous for the human. So this drone was very popular among professional aerial cinematography. Like one of the most popular UAV in the market is DJI Phantom 3. So this is about UAS and UAV. UAS is the entire package of the system, whereas UAV is the part of a UAS, or it is a unmanned aerial vehicle or the actual aircraft that flies to collect the information. Next is the history of UAS. So it was first developed in 1916, and this was the earliest attempt to develop a UAV, and it is done by A.M. Low that used the UAV for aerial target. Then in World War One, Habit separate automatic airplane is developed. It is used for carrying an explosive payload to a predefined target. And after that, in 1935, the first scale remote pilot vehicle was developed by Reginald Denny. And then World War II, the Nazi Germany produced and used UAV during the war, whereas in 1959, US Air Force began planning to use the UAV to reduce the pilot loss. Then 1964, UAV were firstly used for combat mission in Vietnam War, whereas 2012 USAF, that is United States Air Force, employed 7494 UAVs, that is almost 1 in 3 USAF aircraft. So this is the history of US. It is first developed in 1916 and still it is going on development. Then the classification of UAV. So the ICAO, that is International Civil Aviation Organization, classify US broadly into two categories, that is remotely piloted aircraft system and autonomous aircraft. So here in remotely piloted aircraft system, it consists of element like remotely piloted aircraft, and this is associated with the remote pilot station for the required command and controlling link. It means it is controlled and commanded by a human being. Whereas in autonomous aircraft, this type of unmanned aircraft doesn't allow pilot intervention and the management of the flight. So a remotely piloted aircraft system is operated by a human being, whereas autonomous aircraft there is no intervention of the human being. Next classification is based upon the weight. So UAV classification in accordance with weight is, first one is micro. So the micro drone have a weight of less than 2 kg. Mini drone has the having a weight of greater than 2 kg or less than 20 kg, and the small drone have the weight that is greater than 20 kg and less than 150 kg, and large drone will have the weight that is greater than 150 kg. Next is classification from spectrum perspective. So ITU classify US in the following three categories based upon the spectrum perspective, that is small, medium and large. So by spectrum perspective, it means to categorize on the amount of spectrum required for the operation of particular category of US. So like the UA category, that is small category, will fly at the height of less than 300 meter, and its cruise speed is about less than 111 km per hour, and it is tolerance about less than 5 hour, and maximum range is about less than 5 meter, and is according to the visual line of sight. Then there is medium and large. In medium, there is it can attain a height of 300 to 5500, and its cruise speeds lie between 111 to 185 km per hour, and its tolerance is about 5 to 30 hours, and its maximum range is 105 to 258 meter. Whereas large, it has a maximum altitude of greater than 5500, and it has a cruise speed that is greater than 185, and tolerance is about greater than 30 hours, and its maximum range is beyond RF loss. So the next is classification of UAV by control method. So first one is remote human pilot. So it is a UAV that is controlled by the remote pilot, and it is real time control. Whereas remote human operator, here the human use the flight parameter to invoke the built-in function for the vehicle control. And in semi-autonomous, here the human control initiation and termination, and the mission execution is autonomous. Whereas in autonomous, it is automated operation after human initiation. So human will initiate the mission, but it will automate, and the operation is automated. Whereas swarm control, here the cooperative mission accomplishment via control among the vehicle is done. So these are the classification among the UAV by the control methods. Next is the classification of UAV, that is fixed wing and the rotary wing. So there are two types of UAV, fixed wing and the rotary wing. The fixed wings have a lift generated. It will generate a lift by using wings with forward air speed, whereas in rotary wings, it will generate a lift using blades revolving around a rotor shaft. And in fixed wing, it is a simple structure, usually higher payload and having a higher speed. And rotary wing can rover and move in any direction, and it can take a vertical takeoff and landing. Whereas fixed wings have need to maintain forward motion, and it needs a runway. Whereas rotary wing, it usually hover payload, have a lower speed, shorter range, and it doesn't require a runway. The example of fixed wings is Q200 and Datahawk, whereas in rotary wing, example is Y6 and X8. So this is the and this one is the fixed wing drone, and this one is the rotary wing drone. Next, we will discuss about the technologies used and this UAV, that is WAVE and LTE D2D. So WAVE, here WAVE stands for wireless access in vehicular environment, and LTE D2D is 3GPP proximity services, and 3GPP release 14 known as LTE V2X. So here this in WAVE, it support up to 200 km per hour fast mobility, and its range is less than 1 km, and latency, that is delay, is up to less than 100 meter per second. And whereas here physical layer and the MAC layer is based upon IEEE 802.11p, and upper layer based is upon the IEEE 1609 series. And here in LTE D2D and 3GPP release 12, LTE device to device only provides the coverage, and it is only used for the coverage process. In 3GPP release 13, addition of new functions such as relays and priority handling is done. So this is known as LTE V2X, and the wave is known as wireless access in vehicular environment. So these are the two technologies that are used in the UAV. Next is the application. So there are two type of application: military uses and civilian uses. And military uses, the application are international border patrol, road traffic monitoring and control, drug traffic monitoring, or coastline monitoring. Whereas in civilian uses, it can be used for high voltage power line monitoring, environmental monitoring, forest fire detection, crop and harvest monitoring, whereas high accuracy terrain mapping. Whereas it is specially used for the in disasters, like application of drone in disasters are volcanoes monitoring, nuclear radiation monitoring, earthquake monitoring, search and rescue operations, firefighting, catastrophe situation assessment, hurricane watch, and disaster operation management, and the flood watch. So these are the application associated with the drone, and the use cases about the military and the civilian. So this is all about UAV. Thank you.